Okay, so last time we started our kind of high-level introduction to the Ruby language and some of the cooler things about it that you might have been unfamiliar with if you're coming from a language like Java. And we briefly saw one of the interesting things about Ruby is how you can handle iterating through elements of a collection. So I want to spend a little more time on that because the iterators we saw using each, and when I mentioned that you actually shouldn't be doing iteration in an imperative for loop kind of style, but you should be letting the data structures manage their own traversal, that's really just one example of a much more general mechanism in Ruby called yield, which is what we're going to talk about next. And I'm going to start by looking at the way that iterators are typically handled in imperative languages like Java. And if you've seen this kind of Java code before, typically you have some kind of collection, in this case a list. And if you want to iterate over the collection, you hope that it implements the interface for iteration. And you have to set up a new iterator. You periodically ask the iterator if there's any more elements in the collection. And if so, you ask it to give you the next element, and then you do some stuff with that element. And the reason I'm calling this inelegant is that it mixes up two things. In red, there's code that is concerned with doing stuff with elements of the list. And in blue is stuff that's really just the mechanics of getting those elements out. And it would be nice if those things could be better separated. Now, for those of you who are Berkeley students and took 61A when it was still taught in Scheme, one of my personal favorite languages, you actually have already seen this mechanism if you remember things like map and filter. The idea is that you would say map, you would give it a function, and you would give it a list. Now, in Scheme, a list is the only type, so you don't have to worry about what types of things are able to be mapped, because list was sort of your only choice. Well, in Ruby, this more or less becomes the same thing. Remember that the braces can be used in some cases as a substitute for the do and end that would go around a block. So map takes a block of one argument, and it just applies the block to each element in the collection. If you remember filter from the days of Scheme, we have select, which does pretty much the same thing in Ruby. This time I've actually written it out using do and end instead of the brackets. And in fact, you can combine things, right? I can take a map of a lambda expression that operates over a filter, and similarly in Ruby, I can take a list, I can call select to filter out some elements of it. That will return a new copy of the list containing only the filtered elements, and then I can call map on the result of that. So this is one of the ways that Ruby inherits spiritually from functional languages, of which Scheme is sort of an example. And I think of it as turning iterators inside out compared to what you would do in a language like C++ or Java. In Java, you say, you hand me every element of the collection, I'll do something to the element, and then I'll ask you if there's any more elements left. Whereas in Ruby, you go the other way around. You say, here's the thing that I want to do to each element of the collection. You, the data structure, you go ahead and manage the collection so that you can give me each element as needed, and I'm not worried about that part. So let's do a real example of this to show how it would work. So here, I've defined, remember what I said before was in Ruby, the only thing we care about is what methods do you respond to? Well, here I'm creating a class called random sequence. And what this class is going to do is give me back an object that will generate a list of random numbers between 1 and some limit. And it'll generate up to num numbers in that list. So for example, I can call it with 10, 4, meaning I want a new sequence of 4 random numbers between 1 and 10. Okay, so how does this actually work? First of all, I'm going to prove to you that it does work by just pasting this into a Ruby interpreter window. Of course, I have to actually start the Ruby interpreter. Okay, and now I can grab, here's just a little chunk of code that, there we go. So this little chunk of code actually created a new random sequence object, and it called each on it. Right? So remember we said as long as it responds to each is a promise that I can manage the traversal of my own data structure. So in this case, we generated a new random sequence object, and we returned each element of it one at a time. So what does that actually mean? How do we do that? Well, look at our definition of each. We already saw times before. It just says repeat this block some number of times, so however many that second argument was. And what's going on in the block? This is the first exposure many of you have had to this. This is yield. Yield says, transfer control back to the thing that called me because it has a block waiting for me. Right? So down here, when we call random sequence, and the argument to each is this block right here, this block is what's going to get called with the argument of yield. So you can see yield is yielding one value, and this block is set up to take one value. It's one value between the vertical bars. Right? So what happens is each is actually called, and each time we hit yield, yield essentially transfers control back to this point. Right? So this is the turning the iterator inside out. All we had to do was define some way that each would be able to use yield to give back objects one at a time. It is a pretty nifty construct. So iterators are actually just one nifty use of yield. They're the use that we've already seen, and that's why I wanted to start with them. But let me show you another interesting thing you can do, and this is where you start to see how yield can help you clean up and dry out your code a lot better. On the left is a very typical idiom in languages that provide a way to manipulate files. There's a library call to open a file. There's a library call to close the file. And typically what you have to do is you call file open, you do some stuff on the file, and then you close the file. That's probably the way that you're used to thinking about things, but we don't believe in doing things just because we've always done them that way. So what would be a more Rubyistic way to do this? Well, it would be to realize that the pattern of open a file, do some stuff, and close a file is a very common pattern. The open and close parts are the same for everybody. The only part that's different is what happens in between the two. So we can actually use yield to extract them, and this is actually how Ruby's file call works. Instead, we define an open file name method, which does whatever it has to do to open the file to get a file descriptor, and then it yields that file descriptor back to a block. So how does that look like when you use it? In your code, you could say file open with a file name and then present it with a block. Inside the block, you can do stuff with the file. So what's going to happen here? I'm going to call file open. That's going to transfer control up to the open call. The open call will actually open the file. It'll yield the descriptor back to me. So now I'm here, and I can do stuff with the file. When my block is over, where am I? I'm back in this function after the yield. And in here, I can close my file and do any other cleanup. So I've extracted out the common parts, and I've essentially used yield to put something around as opposed to having two separate function calls. I've exposed one call instead of two. Blocks or closures. This is another concept that, although it's taught in 61A and in Scheme, it's not present, or at least not present in an obvious way in a lot of modern languages. A closure is basically the set of all the variable bindings, all the variables with their values that you can see at a given point in time. And if you remember in 61A, they called this an environment, and you drew diagrams about them. Well, that's what this is. Now, what does this mean in terms of yield, and why do we care about it? If we go back to our random sequence example and what was happening here, when we call random sequence new and then we call each on it, what's this variable I? Well, this is just a random, local variable, right? Here it is, I is in scope. But remember what the flow of control is, right? We're going to call each. Now we're in this function. Each calls num times. The first time we hit yield, we're back down here. So if you think about where in time is this block getting executed? Well, it's getting executed at the time that yield is called. But despite that fact, it has access to the variable I, which was in scope at the place where the block was defined. So this is actually a pretty deep concept, right? It means that when you create a do block, all of the variables visible inside that do block are going to be visible and have those values, even if the block is being executed at a place and time far away from where you defined it. And a place later in the course, or in the case of the online course, this is in part 2, where we're going to see this again is in JavaScript. JavaScript makes extensive use of closures, and it's one of the reasons that beginners in JavaScript tend to write horrible, horrible code, because they don't understand this very powerful concept that you can define a procedural environment that always carries its variables around with it.